So, integration by parts. What do you do here? What we're doing with integration by parts is trying to integrate the product of two functions. So we've got, it's u times v is what we're trying to do now. And with the first thing you want to do is try to do a u substitution, because that's the easiest thing to do, and you try to do it. So if I try for this one, well, let's see. If I say u is x, du is dx, I still don't have, like for this one, I would still have the integral of u times e to the u du. I haven't done anything to make this simpler. So we need to try have a different trick, and that trick is integration by parts. Okay, so there's a formula for it. You can certainly look it up online, but what we have is, and it's on this handout, if I have u times v, what you're trying to do is dv. What you're trying to say is one of these is a function, another one is the derivative of a function. And so what we do is break it up into parts. And what, as you see from this table for this example too, you're going to decide one of these functions is going to be the u, and one of them is going to be the derivative of another function. And what you try to do with this is you try to pick one problem that's really easy to differentiate, and one problem that's really easy to integrate. And now with this one, it would be kind of a toss-up what you use when. So there's this little what's it called? Mnemonic that'll help us decide on what each of these is called, which one to use for u. So this is what you're going to use for u. The L stands for, you're going to use a log function, ln or logarithm. The I stands for inverse trig. So if you have an inverse trig function, you want to choose that for u. P is a polynomial. That's what we have going on here. E is exponential. And the last one is the trig function. Okay, so this is what you want to choose for u. Lipit. So for this function, to integrate this function, I have a polynomial going on here, and that comes before an exponential. So I'm going to say u is x, and then I'm going to say e to the x dx is going to be what my dv is. Okay, so that's the first part, that's the second part. You can see dv. And now what you're going to do is you're going to take the derivative here, so that's just 1 dx. You take the antiderivative here, which is going to give me an e to the x. Okay, now to get the integral, the rule for integration by parts is you do u times v minus the integral of v du. So what that means is I'm going to multiply across for the u times the v. So it's x e to the x minus the integral so these two here come from this part. You multiply those two across the table. So that's e to the x dx. Now what we have is we've still got another integral, and we've got to integrate this. However, the antiderivative of e to the x is really easy. That's just e to the x. So I've got x e to the x minus e to the x plus c. And that is the antiderivative of that function. Now, just on the off chance that you haven't seen this website yet, if you go to Wolfram Alpha, this will do a lot of the math for you to check your answer, to check your steps. On the mobile app, it's a cheap purchase. It's like $6, and it does a lot more for you. Here, you got to sign up, they'll only give you 3 exact solutions per day. But what I'm doing here is I'm integrating. I just typed in integrate x e to the x, and of course it gives me a bunch of choices. Try to clear that. Okay. So if you just integrate that, let it do its thing. Do you see right here? It gives you a bunch of stuff. Sometimes you got to drill down. This is what it told me to do. If you clicked on step-by-step solution, you have to sign in, do a login. Then there's a paid app. I don't remember what it costs online, $10 or so. I wouldn't do that. Okay, so but that is just the factored form of what we had. See down here how it has the x e to the x, or e to the xx minus e to the x plus this constant. So this is a tool that you don't want to ignore. This will help you do a lot of work with it. There's a calculus Wolfram Alpha for iOS that's like $3 that's worth the money, and then you can buy the full Wolfram Alpha. I don't know about on Android. Okay, so that's your first integration by parts problem. So we do, remember the formula is u times v minus the integral of v du, where you do that cross, and don't forget Lipit. Okay, so here's another problem. So if we think about Lipit, I see a polynomial. So that's what I want to let be u. And then I'm going to write, oops, I messed this up. Lipit logarithm. I see a logarithm. So that's going to go first. ln x, that's my u. And then so that'll tell me x squared dx is the problem. Now the reason I knew that, the reason I knew I had made a mistake, and I guess I'm glad I did, is I was looking at ln x dx and I said, how the heck do I find the antiderivative of ln x dx? Well, that's a problem in itself. So I knew that was the wrong choice for my dv. So that's what made me take another look at what I had chosen. Okay? So then what we do is we take the derivative. So derivative of ln x is 1 over x dx. The antiderivative of x squared is, of course, 1/3 x cubed. And then we got to remember the integration by parts formula. Whoops, du. Here, I'll make that look like a u. Okay, so we're going to do 1/3 x cubed times ln x minus the integral. Now here's the tricky part. Actually, it isn't tricky. The 1/3, so what I'm doing here is I've got 1/3 times x cubed times 1 over x dx. Well, the 1/3 is a constant. Constants can come out in front of integrals, so we don't have to worry about them. And then I've got x cubed over 1 times 1 over x. Well, I can cancel out one of those x's. Okay, so now I've got taken care of the first part. Now I'm going to take the integral again, but that's pretty easy. The antiderivative of x squared we've already done once, so we know it's going to be 1/3 x cubed, and I've got this other 1/3, so that's going to give me 1/3 x to the third ln x minus 1/9 x cubed plus c. And you can go out and check that out on Wolfram Alpha if you want. Alright, here's the problem, and they have a typo in this sheet. Hey, this is a pretty classic problem, and you'll do enough of them, certainly in Calc 2, that you won't have to, you'll just remember this. That e to the x shouldn't be here. That x e to the x shouldn't be here. What we're going to do is we're going to think about Lipit, And what I have here, do you see how I just have ln x and dx? Well, that's exactly what you're going to do. You're going to let u be ln x. You're going to get dv be dx. And then what's the antiderivative? What's the derivative of ln x? 1 over x dx. What's the antiderivative of 1 dx? Just x. And then we're going to do the u times v. So x times ln x minus the integral. Well, what is x times 1 over x dx? Well, the x's cancel out, thank goodness. So I'm just left with 1 dx. You can write 1. I'm just going to write the dx. So I'll write 1 just to make us happy. So what's the antiderivative of 1? Well, it's just x. And then you need plus c. So the antiderivative of ln seems complicated at first, but it's not that bad. Okay, next problem. Here he says, when things go wrong. So, what do we do here? If we use this combination, this choice of u, now remember the Lipit, we're supposed to be using a polynomial before an exponential. So that's the thing that went wrong, and this is why this was invented. If I do this work here, I'm going to get 1/2 x squared. I'm going to get e to the x dx. When I use my integration by parts formula, 1/2 x squared times e to the x minus the integral. Well, let's pull the 1/2 out in front. X squared e to the x dx. We had this that was just x e to the x. And now we've got an integral that's x squared e to the x. We went the wrong way. We're not getting an easier integral. We're getting a more difficult integral. So that's a clue that you did something wrong. Okay, now this is another problem. If we try to do an integration by parts on it, and even if we choose to use Lipit, where we're going to use the polynomial before we have the exponential, so if I choose 2x here, I could pull the 2 out and have ex squared e to the x squared dx. Well, taking the derivative of this is easy, but how the heck do you find the antiderivative of e to the x squared? Not an easy thing to anti-differentiate. So we chose the wrong way. How about if I did it this way? What if I say e to the x squared is u and 2x dx is that? Well, if I do the derivative of this, I get e to the x squared times the derivative of the x squared, so 2x. I'm hoping you're seeing that I'm still getting something that's really, really strange. Okay, so that what he tells you in this hint, this is not an integration by parts problem. It's a substitution problem where you're going to say u equals x squared, du equals 2x dx, and then you just take it from there. You know what to do with that, right? E to the u du, and I need to pull the 1/2 out in front. Okay, so that's that. All right, so how about this? So he's telling you choose wisely. So we're going to look at this. I'm going to use an inverse trig function as the u and the dx. So arctan x, and that's dx, and the antiderivative of that is x. We got to find the derivative of arctan. I'm hoping you've started and have done enough of these now that you maybe can just jump right to the answer, but just in case you haven't, I'll work this one out. Take the tan of both sides. So 1 over x, so that's x over 1, that's x, that's 1. This is the square root of 1 plus x squared, or x squared plus 1. Now if I take the derivative, I'm going to get secant squared y dy dx equals 1. So dy dx equals 1 over secant squared y, or cosine squared y. Well, the cosine of this graph is 1, or this triangle is 1 over the square root of 1 plus x squared. If we square that, we're going to get 1 over 1 plus x squared, or x squared plus 1. Okay, so that part's easy. Now we can set up our integration by parts formula. X arctan x minus the integral of x over 1 plus x squared dx. Okay, so we're on the way. Now we're going to find the antiderivative of x over 1 plus x squared. Well, that looks suspiciously to me like a u substitution, where if I say u equals 1 plus x squared, and I say du equals 2x dx, 1 over 2 du equals x dx, and then you can use that substitution. Let's see, where's our highlighter? We can use that substitution right there, right? So I'm going to say the integral of du over u, or 1 over u. Well, the antiderivative of 1 over u is ln u. So minus ln. I'm going to use absolute value sign, so I don't need it for this problem, because 1 plus x squared will always be positive. So x arctan x minus ln of that plus c. If this were a multiple choice test, they just might make you do x arctan x plus ln of 1 over 1 plus x squared, to use that negative exponent, right? Bring that negative exponent up. They might do something like that. Okay? All right. So sometimes you got to do this. Actually, what I'm going to do, folks, I'm going to stop and go on.